Everyone, so this is a tutorial on how to run the neural network to that for the Fuelmap classification. So you should have tagged at least one TIFF file using QGIS and then rasterize the results, and then that result should be on your computer somewhere, and therefore you can actually use it to train the neural network along with the original TIFF file. So for example, if you were doing this, let's say if I go up here, right, the original file was, go up, right, let's say this HXIP, right, 3711955 Northwest, right, you should have this file and the tag file, which is usually going to be underscore your initial and then maybe like the month also. And that way you have both of those files, both of those TIFF files, one for training, the other one for the classification. Okay. In order to do the classification, what we need to do is we need to run Python. So what I'm going to do is I'm going to install Python. Okay. And the version of Python we need, go back down here, installing Python, right, is 3.7. So unfortunately, we've seen there's a problem with later versions of Python because a couple of libraries that we use, GDAL and raster.io, are not updated for those Python versions yet. So what you want to do is go to the Miniconda website. So I install through Miniconda because it's a nice, cleaner way to install Python. Okay. So when you go here, you're going to get a different version. Actually, it's 3.12 right now. So what we need to do is actually go to the archive version, click on this little link here, right? So what you need to do is go back down to 3.7. Where's the sevens? Down. Oh, there's sevens right here. Okay. 37412. Okay, I think the 412 is like the Anaconda version. So these are sorted by dates, so we'll grab the latest one. So the Windows is for Windows, the Linux for Linux, the Mac for Mac, of course. Okay, so I'm going to download this version. Okay, actually, is that the wrong one? Yeah, so x86 means not 64-bit operating system, so I'm going to download the 64-bit operating system up here instead. Okay. Okay, you notice that it's pretty quick, right? Because it's mini. I'm going to delete the 64-bit version, the 32-bit version, and only run the 64-bit version. So I'm going to install that. Okay, so when you install, you're going to click through a few windows, right? This is the license agreement. Install it just for yourself. If you have another version of Python installed on your computer already, unfortunately, you're going to have to make a new account on your computer. Well, this is specific for Windows. And then, right, and then on that new account, install Python just for yourself. And that way you don't conflict the different versions of Python on your computer. It's interesting. It says Pi 2.3.8. I downloaded the wrong version, didn't I? So I'm going to cancel this. Go back to my download page, right? I want the 64-bit, but not 3.8. I want 3.7, which is this one here. Refresh this. I can delete the 3.8. So install that by accident. Okay, 3.7. Okay, so you have this little page here. Next, just me, and then just accept the default setting there. And yeah, register Python as the default Python. You don't have to add the environmental path. In fact, they don't recommend it because what's going to happen is that they may conflict with other Python activities that your operating system might be using. Okay, so install this. Okay, so it's done installing. You can then check all these tutorial stuff. Okay, what we're going to do now is we're going to run this thing called the Anaconda prompt. So if you click on your Windows and then Anaconda prompt. Okay, so Miniconda, right? Click on that. What that's going to do is going to bring up like a little black box like this. Okay. In fact, I'm just going to keep following the tutorial, so I don't need this anymore, right? Right. What it tells you to do is create an environment called Fuelmap. Right. Let's put this on the top left here. That's my email. Okay, and then put the Anaconda prompt up on the right here. Right. So the next step is to create an environment called Fuelmap. It'll be very quick. Next step, you have to say yes to it. Okay. And we're going to activate it. So now instead of base, we're now in this environment called Fuelmap. And what we're going to do is we're going to install specific packages into Python, namely Conda Forge, Fiona, Shapely, Raster.io, Panda, Jupyter Lab, which allows you to run the notebooks, Matplotlib, and then Scikit-learn. Okay, so while that installs, I'm going to pause the video. Okay, so after Anaconda, all those packages gets installed, right? I'm going to skip to the part where you actually start running things. So, well, this is still installing, so this install may take more than half an hour. So what you want to do after that gets installed is you run the code, you activate the Fuelmap environment, and then you just run Jupyter Notebook as using just Jupyter-Notebook exe in this prompt that's going to pop up after this. Okay. What happens is that when you see, after you run that, you're going to get a page like this. Okay. And you know, this is basically your the files in your computer. But right, wherever you put your data file. So in my case, I put it in this folder called Fuelmap. Okay, that's where all my tagging and stuff is done. Okay. What you need to do is to actually download these 3 files. Well, the third one is for multi-map code, but at least you need these 2. Let me just sort them. Oh, okay. I think you can see all 3 right here. Right. So you need MLP Fuelmap single map, IPython notebook, and then also this Fuelmap IPython notebook at least. You might as well download the multi-map one too. Where you get that, you can get that on GitHub. Okay, on my GitHub account, there's an updated version of this. Okay, so you want to download all 3 of these files. Okay, put it in the same folder. Okay, well, actually put it in the folder where you want your Fuelmap, all your map data also, so that you don't have to deal with changing directory when you're running things. Okay, so when you do that, once you have these files here, you're not going to have as many a TIFF file. I think you will just have one tag file, one TIFF file following this tutorial. What you want to do is that you want to click on this code here, okay? And the instruction is pretty old, as you can see, okay? But I have been updating the code, okay? So this is just the instruction box, so you don't need to click on that. The first thing you need to do is actually run this first box, okay? What this is doing is actually loading a bunch of functionality, right? Load training data set, load this RMS deviation, how to print stuff, how to predict stuff, okay? Okay, that loads all the functionalities. The next box of code, okay, is where you actually enter in the files you tagged, okay? In my case, so by default, it's not going to have the right file names for you, okay? And this is also a Linux computer. So in Windows, you may have to do backslash instead of slash. So just be careful about that. these may be backslash to you to those who are using Windows computer. Okay, but what you want to do is basically put in the file name for the image file, meaning the one that you did not tag, the original data file. Okay, and you want to put in the tag file. Okay, the tag file is the one you just created by the rasterization function in QGIS. The output file, this is going to be generated for you, so this doesn't exist yet. But what you want to do is just name it the same way with the same conventions before, with the number Southwest 11_100, and then add NNRMSD to it. NN stands for neural network. RMSD stands for root mean squared deviation. So this is the two algorithm we're actually going to run to produce how good this classification algorithm is. Okay. The rest of the code you should not need to really modify or tweak. So hopefully you can just run this straight out of the box. Okay. So after you modify these file names, okay, what you want to do is just push either run up top. Well, might as well do that. Okay. So it's going to run this function. Okay. It's going to tell you how many of each of the pixels you tagged. Okay. And it's going to run the fit, which is training the neural network. And then it's going to predict using that train neural network in order to predict what the pixels identifications are: tree versus grass versus unburnable, dry versus not dry, right? Then it's going to run this statistical analysis called RMS deviation, which is what Taylor and I developed a year and a half ago, that allows you to differentiate basically green trees and green grass. The problem is that since both of these objects are green, if you do a pixel by pixel analysis, you actually cannot differentiate the two. So therefore, that's why you want this green tree, green grass, a differentiation using a statistical analysis. So while that's running, I'm going to pause the video real quick. Okay, so when the analysis finished running, you should see two plots, and it's very important to actually know how to interpret these two plots. So the first plot is the RMS deviation plot. So the red histograms here is shown where the values for where objects are tagged as green grass. Okay, and then the blue ones are the ones that are tagged as green trees instead. Okay, so you can tell that the red tends to be on the left, the blue tends to be on the right. The reason for this is that trees, since it creates shadows and there's leaves and all kind of structure, three-dimensional structures to it, it'll tend to have a larger RMS deviation. So that's how we actually differentiate between the two. But you can tell that there's some overlap between the two, so the cut is not 100% clean, but it's better than nothing. So that's how you interpret this plot. Just make sure that this crossover point, which you can actually set in the beginning of the script up here, right? That's actually around where the red and the blue actually crosses. The other plot that comes out is this confusion matrix. Okay, so what's happening on the left is what you tagged as unburnable, green grass, dry grass, green tree, dead trees. Okay, and then the horizontal is how the algorithm determines, that this pixel actually went into unburnable, green tree, dry grass, green grass, dry grass, green tree, dead trees, right? So you can see that all of these are pretty good when they're red, because that's above 85%. This little orange part here is probably hanging around 80%. And that's going to be kind of expected between green grass and green tree, because, right, we're running this additional algorithm to it in order to differentiate green grass and green tree. And this is actually going to have an accuracy probably, if you can get 90%, that's really spectacular. But we're expecting this to be 80-ish percentage, okay? All right. So what you want to do, and then on the bottom here, it actually even prints out all the values from this confusion matrix, okay? So that's actually kind of nice. So green trees actually 85%. The green grass is actually 75%. So that's actually kind of bad. So maybe what you want to do is actually shift this a little bit So if the green grass is too inaccurate, meaning, right, you have the bunch of green grass here, right, that you tagged as green grass, but sorry, you have a bunch of green grass that you tagged here, okay, but are not correctly identified as green grass, okay. You may want to shift this to the right in order to identify more of those green grass. But then what's going to happen is that the green tree will become less accurate. So it's, this dial basically allows you to dial between the green grass and the green tree accuracy. Okay. So after this algorithm finish, it's actually going to write the TIFF file, which is what you determined from this output parameter here. Okay. So what I want you guys to do to beginning especially is to tag a couple hundred pixels at a time of each, right? Don't go don't do like 10,000 pixels of each and then figure out, oh, I tagged everything wrong. Okay. The dead tree is usually going to be the hardest to find because they're, as I show you guys in the tagging video, right? You have to tag like 10 pixels at a time. So unfortunately, that's a lot of the work. Okay. You don't want to tag too many of each pixel. There's probably too big of a difference between dead trees and green grass here already. So, my next task in this map is probably going to be just tagging more and more dead trees, okay? Because what happens is that if you tag too much of one thing, it's going to bias your algorithm towards that, okay? And so that's how you basically figure out whether or not your tagging algorithm is actually working. And in a later video, I'll show you guys what the other functionality in here is used for, this prediction only cell and also the multi-map predictor, okay? But this should get you going so that you can actually, tag maps, run the algorithm, see if it works. And, if green tree is being mistaken as unburnable, something like that, that means you're probably tagging something wrong with that, okay? And that way you can get some feedback on how to fix things. All right.